Hello students and welcome back to my channel Maths Hub by Dr. Tanya Bose. So I hope you enjoyed my first lecture. So coming to the second lecture, in the first lecture I talked about cosets and about comparable and incomparable elements, right? So in the second lecture I'm going to talk about a very important topic, that is a Hasse diagram. So I'll explain you the Hasse diagram with the help of an example. Now, Hasse diagram plays a very important role in the construction of a lattice, right? So you must know what is the steps or what is the concept behind drawing a Hasse diagram. So I'll explain you with the help of an example. So let us take one example where the set A is given to us as 1, 2, 3, 4, and the elements of the relation are given to us as 1, 1, 1, 2, 1, 3, 1, 4, 2, 2, 2, 3, 2, 4, 3, 3, 3, 4, and 4, right? So while we are constructing a Hasse diagram, in my first video also, I talked about a digraph, right? So digraph is nothing but a pictorial representation of a given relation. So you know that a picture is better than, writing a paragraph. So that is why we always try to represent our things in the form of a graph. So you can see this whole relation is being depicted with the help of this graph. So how is this graph drawn? I'll just show you. So you can see that the relation is defined on the set A, and set A has 4 elements. So these 4 elements will serve as the nodes of this graph, right? So this is node 1, this is node 2, this is node 3, and this is node 4. Now you can place these nodes anywhere you like. It's not necessary that you have to maintain a pattern of a square. You can keep it anywhere, right? So now let's join them as the relation is given to us. So the first relation is 1, 1. So 1 means that we have to join 1 with 1. So it's a self loop. Next one is 1, 2. So that means 1 connects 2, and we will put an arrow marking that 1 is related to 2. 1 relates 3, so we will join 1 with 3. Then we have 1 relates 4, so we will join 1 with 4. Then we have 2 comma 2, so 2 is joined with 2 with the help of a self loop. Then we have 2 comma 3, so 2 connects 3. Then we have 2 comma 4, so 2 connects 4, right? Then we have 3 comma 3, so 3 connects 3. Then we have 3 comma 4, so 3 connects 4, and finally we have 4 comma, right? So the first step in the construction of a Hasse diagram is drawing a digraph, right? Now, from the digraph, so you can see that the digraph is not a unique structure, isn't it? If you draw the nodes at different positions, the structure of this diagram would be different than what I have drawn, right? But it's not that you have drawn it wrong. That is also correct, right? So it depends that where you have placed the nodes, right? So the first step is drawing the digraph. Now, after you have done the first step, the second step is remove all the reflexive pairs. Remove the reflexive pairs. So in my first video, I talked about reflexive relations. What are reflexive relations? The elements which are of the type A comma A. So you can see that A comma A means we have 1 comma 1. So we will remove this 1 comma 1. So we will remove this 1 comma 1. Then the next reflexive pair is 2 comma 2. So we will remove this reflexive pair 2 comma 2. Then the next one is 3 comma 3, and the last one is 4 comma 4, right? Now after removing the reflexive pairs, what is the third step? So second step we are done. The third step is remove all the transitive pairs, right? Again, in my first video, I have explained you what are transitive relations. So transitive relation means when A and B are in the relation, B and C are in the relation, then A comma C should be in the relation. So when we have to remove the transitive pairs, we have to remove the pairs of the type A, comma C. So let us see in this diagram which all transitive pairs we have. So the first transitive pair that I can see is 1 is related to 2 and 2 is related to 3. So you can see 1 and 3 are also related, right? So we will remove the transitive pair, that is 1, comma 3. Let me put a cross over all the relations that I have removed. I have removed 1, 1, I have removed 2, 2, I have removed 3, 3 and I have removed 4. Now I am next going to remove the transitive pair, that is 1, 3. And how did I remove 1, 3? Since 1 is connected to 2 and 2 is connected to 3, so this is giving rise to 1, 3. So I need to remove this pair 1, right? So let us remove this pair 1, 3. Okay. After removing the pair 1, 3, let us search, do we have any other pair left? Again, I can see the next pair. 1 is related to 2 and 2 is related to 4. So this leads to 1, 4. So I need to remove the pair 1, 4. So let us remove 1, 4 from here. Now again check in this diagram. Are we left with any other transitive pair? So you can see that 2 is related to 3 and 3 is related to 4. So that leads to 2, comma 4. So we will remove this pair 2, comma 4 also. Right? So let us remove this pair 2, comma 4. Now once you have removed all the transitive pairs, once all the 3 steps are done, recheck whether anything is left now. So now you can see that nothing is left. Right? So now how to draw the Hasse diagram? In Hasse diagram, you have to keep in mind two things. One is that you have to maintain a hierarchy, right? Now what is a hierarchy? You might have seen that in army, military, navy, there are different cadres, right? So the lowest rank cadre, then we have upper than that, and it goes on and we have the topmost cadre there, right? Similarly, when we have to maintain a hierarchy, we will place the lowest element at the bottom position and we will place the upper highest element at the topmost positions, and the rest of the elements will be placed according to a rank, right? So we will always move from bottom to top, never from top to bottom, right? The second thing that you have to keep in mind while drawing the Hasse diagram is that if A is related to B, then what are the positions of A and B? A will be kept below and B will be kept above, right? Similarly, if B relates A, then B will be kept below and A will be kept above, right? So now let us try to draw the Hasse diagram for this structure. So after you are left with the relations that are left in this, how to maintain it. Now, which is the lowest level element? From where is everything getting started? Everything is getting started from the element 1, right? So we will keep 1 at the lowest position, right? So I'm keeping 1 at the lowest position. Now from 1, you can see how is the relation defined. 1 relates 2. The arrow is marking towards 2. So 1 relates 2. What is the meaning of 1 relates 2 according to this? That 1 will be at the lowest position and 2 will be placed above it. Right? So what we will do, we won't put circles on this. We will simply put a dot. So the lowest dot will represent 1. Then 2 will be placed above it, and we will join it with the help of a line, right? So 1, 2 is done. Next line that is left is 2 related to 3. So you can see that 2 relates 3. If 2 relates 3, that means 2 is at the lowest position and 3 will be placed above it, right? So we will join again 2 with 3. So this is also done. And then now we have reached 3. 3 connects 4. That means 3 is related to 4. So we will join 3 with 4 over here, right? Now in the Hasse diagram, what difference do you find? You can see that in the diagram, everywhere there is an arrow over every edge. But in the Hasse diagram, there are no arrows, right? Why there are no arrows? Because I told you that there is a hierarchy. this diagram itself explains us that 1 is at the lowest level and 4 is at the topmost level, right? And we will always move from bottom to top. We will never move from top to bottom. So this shows that 1 relates to, 2 relates 3, 3 relates 4. And I told you that why did we remove these transitive pairs? Because when 1 relates 2 and 2 relates 3, 1 automatically gets related to 3. Similarly, if 2 relates 3 and 3 relates 4, so 2 automatically gets related to 4, right? So to remove these duplicacies, we have removed the transitive pairs, right? So this structure that is obtained now, this structure will be the Hasse diagram for the given relation, right? So I'll again just revise what steps we have done. From the given relation, we will draw the digraph. From the digraph, we will remove all the reflexive pairs. Then we will remove all the transitive pairs. After removing all these 3 steps, whatever digraph is left, we will see that from where we need to initiate it, where is everything initiating from, so that level will be at the lowest position. And then we will check the connectivity of the digraph and we will place the elements accordingly, right? I hope so the first example is clear. So let's discuss few more examples so that this topic is very clear to you. So these are just steps explained. So after removing the transitive relations, which pair are left, and then how do we draw the diagrams, right? So now let's see the next one. So these are the 2 important remarks that I have already told you. That if there are 2 elements, when we say that A relates to, what is the meaning? That they are comparable elements, right? I have already explained you what are comparable elements in my first video. So whenever A relates B or B relates A, that means they are comparable. So any 2 comparable elements, how are they placed? If A is related to B, then A always lies below B. So this is the position according to the Hasse diagram, right? And second remark says that non-comparable elements are not joint. So if 2 elements, if there is no relationship between the 2 elements, then those 2 elements are non-comparable and they will never be joined, right? So you can see that in the Hasse diagram, there are no horizontal lines, right? You will always find vertical lines in your Hasse diagrams, but if 2 elements are placed in this way, if I write A and B here and there is no line joining them, that means they are not comparable and non-comparable. That means there is no relationship between A and B or B and A, right? So if these 2 remarks are clear to you, then you can draw the Hasse diagrams very easily, right? So let's talk about another example. So the next set is set A is 1, 2 and we are defining a power set on this set A. So power set of A means all the subsets that we get from the set A, that is 1, 2. So the first subset is always an empty set, 5. Then the second set is singleton set 1. Then we have singleton set 2 and then we have the complete set 1, 2. And these are all the elements of the relation that are given to us, right? So now, the first step is you have to draw the digraphs. So there are again 4 nodes in this power set. So we keep the first node 5 over here, 1 over here, 2 over here and 1, 2 over here, right? So you can see that we have self loops 5, 5, 1, 1, 2, 2 and 1, 2 and 1, 2. So all the self loops are drawn, right? Then we have the other relations 5 connected with 1, this one, 5 connected with 2, this one. Then we have 5 connected with 1, 2, this one. Then already we have done this. 1 with 1, 2, so 1 is connected with 1, 2. Then we have 2 connected with 1, 2. So these are all the relations that we have drawn over this, right? So from the digraph, we move to the first step. The first step is remove all these reflexive pairs. So we remove 5, 5, we remove 1, 1, we remove 2, 2 and we remove 1, 2 and 1, 2. So you can see all the self loops have been removed, right? After removing the self loops, we get this graph, right? Now, the third step is we need to remove all the transitive pairs. So which pairs are transitive? You can see in this graph. 5 related to 1, 1 related to 1 comma 2. So 5 relates to 1 comma 2. So this is the transitive pair. So let's remove this. So we will remove this pair. And whatever digraph is left now, you can see there are no more transitive pairs, right? So let's move ahead and see that what is left after removing the transitive pairs. So after removing the transitive relations, we are left with this graph, right? So now you can see that at this stage, all the reflexive pairs have been removed, all the transitive pairs have been removed, right? Now how to draw the digraph for this particular relation? So again, if you study this digraph carefully, from where is everything getting started? It is getting started from the element 5, right? So let's place 5 over here, right? Now, let's see in the digraph, what is the next step? You can see there is a relation from 5 to 1 and there is a relation from 5 to 2. So that means 5 is related to singleton set 1 and 5 is also related to singleton set 2. That means if phi is related to 1, the positions of phi and 1 should be like this. And if phi is related to 2, that means phi should be again below and 2 should be above it. Right? That means there are two elements which are above phi. But then we have to decide that what should be the levels of 1 and 2. Is there any relationship between 1 and 2? Is 1 related to 2? 1 is not related to 2. That means 1 and 2 are non-comparable elements, right? If 1 and 2 are non-comparable elements, that means you can place them at the same level. So, what we will do? We will place 1 and we will place 2 at the same level, right? I hope this step is clear. Since phi is related to 1 and phi is related to 2, so for both the cases, remark number 1 said that phi should be below and 1 and 2 should be above it. But then we need to decide that how can 1 and 2 be placed. If there is no relationship between 1 and 2, that means 1 and 2 are non-comparable elements. So you can always place them at the same level. So let us join phi with 1 and phi with 2. It is very important to put these elements at the same level. If you're not putting them at the same level, then your Hasse diagram is wrong, right? So we have done phi and 1, we have done phi with 2. Now next step, let's see how it connects further. You can see that 1 is related to 1 comma 2 and 2 is also related to 1 comma 2. So that means singleton set 1 is related to the set 1 comma 2 and singleton set 2 is related to 1 comma 2 and everything is ending at 1 comma 2. That means at the next level we have the element 1 comma 2 and we will join 1 with 1 comma 2 and we will join 2 with 1 comma 2. So this is also done and this is also done. So this is your Hasse diagram that we, right? So you just need to, it needs a little practice, and secondly, you have to just think and see how you can place the elements so that you get a symmetry in the shape, right? So phi is at the bottom position, then the next level goes to 1 and 2, and the third level goes to 1 comma, right? Let's see another case. So we have the next as 1, 2, 3, 4, 5 and now the relation is given to us as less than equal to, right? So how are two elements related? A is related to 2 or A is less than equal to B. So which all elements, so let us state which all elements will there be in the relation. So we will have 1 comma 1 because there is equality symbol. Then we will have 1 comma 2. We will have 1 comma 3. We will have 1 comma 4. We will have 1 comma 5. Then with 2 I will have 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5. Then with 3 I will have 3 comma 3, 3 comma 4, 3 comma 5. Then with 4 I'll have 4 comma 4, 4 comma 5, and with 5 we can have 5 comma, right? So you can see that this procedure was quite long. We were drawing the diagram, and we were removing the reflexive pairs and the transitive pairs, and then we were drawing the Hasse diagram, right? So what is the shortcut? Once you know which all elements are there in the relation, without drawing the diagram, you can do the first two steps, right? So this thing, what is your diagram going to be? So we will not draw the diagram. From this relation itself, let us try to cross all the elements that are not required in my Hasse diagram. So according to step number 2, we do not need the the reflexive pairs. So we can remove 1, 1, we can remove 2, 2, we can remove 3, 3, we can remove 4, 4, we can remove 5, 5, right? Once these elements are removed, what is the next step? We were removing all the transitive pairs. So which elements are transitive now? Let us see. 1 is connected to 2 and 2 connects 3. So that means 1 connects 3. So we'll remove 1, 3. Okay, what is the next pair that you can check over here? 1 related to 4, 4 related to 5. That means 1 related to 5. So you can remove 1 and 5, right? Then 2 related to 3, 3 related to 4. So 2 related to 4, right? Then 2 related to 3, 3 related to 5. So 2 related to 5. So this also gets removed. 3 related to 4, 4 related to 5. So 3 related to 5. So this also gets removed. Anything else that you can see can be removed? Do you find any other transitive pairs? Okay. So I don't think so. Any other transitive pair is left. Done. So now let's try to join this. I think 1 comma 4 should also get cancelled. 1 is related to 2 and 2 was related to 4. So you can cancel off 1 comma 4 also, right? So now we are left with 1, 2, 2, 3 and 3, 4 and 4, 5. So these are the elements left. So now the first element pair that is left in this is 1 comma 2. It is starting from 1, 2. So 1 is related to 2. That means 1 should be at the lowest level and 2 should be above it. So 1 is connected to. So we are done with this. Let me just put a tick over this element. The next element is 2 comma 3. So 2 is related to 3. 2 related to 3 means again 2 is at the lowest position. 3 is above it, and we'll join 2 with 3. So 2, 3 is done. Then we are left with 3, 4. 3, 4 means 3 is related to 4. So 3 is below and we'll place 4 above it. So this is how we get 4. Then 4 comma 5. So 4 below, 5 above it, and this becomes my right. Okay, I'll just explain one more example with you, and I'll give you some exercises to practice. So now 1, 2, 3, 4, 6 and 12, and we have the relation as divisor. Now what is the meaning of this divisor? Divisor means that if I have two elements in the relation, that means A divides B. And what is the meaning of A divides B? That means B should be a multiple of A, right? So let us list out all the elements in the relation R, and then let's try to draw the Hasse diagram. So the first element that comes in the relation is 1, 1, because 1 always divides 1. 1 divides 2, 1 divides 3, 1 divides 4, 1 divides 6, 1 divides 12, right? Then let's start with 2 now. 2 divides 2, 2 divides 4, 2 divides 6, 2 divides 12. With 3 we will have 3, 3, 3 divides 6 and 3 divides 12. Then with 4 we have 4 divides 4, 4 divides 12. And with 6 we'll have 6 divides 6, 6 divides 12, and then finally 12 divides 12. So these are all the elements in the relation. Let us cancel all the reflexive pairs. 1, 1, 2, 2, 3, 3. Then we have 4, 4, 6, 6 and 12. Right? Now, 1 related to 2, 2 related to 4. So 1 related to 4 gets cancelled. 1 related to 2, 2 related to 6. So 1 gets related to 6, transitive pair. 1 relates to 2, 2 relates to 12. So 1 relates to 12, so this gets cancelled. With 3, 1 relates to 3, 3 relates to 6. So we have already cancelled 1, 6. 1 relates to 3, 3 relates to 12. So 1 related to 12 is already cancelled. 2 relates to 4, 4 relates to 12. So 2 relates to 12, cancelled. 2 relates to 6, 6 relates to 12. 2 relates to 12, cancelled. Then 3 relates to 6 and 6 relates to 12. So 3 relates to 12. That is also cancelled. Right? So these are the pairs that are left out. Right? So now let's try to draw the Hasse diagram. So to begin with, we can see that the relations are starting from the element 1. And now we have two relations. One is related to 2 and one is related to 3. Right? We are given these two relations. So if 1 is related to 2, that means according to remark number 1, 1 and 2 should occupy this position. And if 1 is related to 3, so 1 and 3 should occupy this position. Now let's see what about 2 and 3. Are 2 related to 3? 2 is not related to 3. You can see in this. So if 2 is not related to 3, that means 2 and 3 can occupy the same positions. So how to draw it? We will keep 1 over here at the lowest level and we place 2 and 3 at the same levels and in the next position. So 1 is related to 2 and 1 is related to 3. Right? So these two elements are done. Now let's see what about 2 and 3. At the next levels we have the elements 2 and 3 over here. So 2 is related to 4, 2 is related to 4 and 2 is related to 6. That means 2 is below, 4 is above it. Similarly 2 is below and 6 is above it. Right? Now if I talk about 3, 3 is related to 6. So 3 is related to 6 means that 3 is below and 6 is above it. So already we have to now start from 2 and 3. That means I can clearly see that in the next level, which elements are appearing? We are getting two elements, that is 4 and 6. 6 is common in them, right? 4 and 6. So that means two elements are exactly in the next level. So if there are two elements according to symmetry, I'll keep 4 over here and I'll keep 6 over here. And let's join all the relations. 2 was related to 4, so this gets joined. 2 is related to 6, this gets joined. 3 is related to 6, so this gets joined. Right? Now, next. Now we have reached 4 and 6. So from 4 and 6, let's see which our relations are left now. 4 is related to 12 and 6 is related to 12. That means in the next level, I'm only getting one element, that is 12. So according to symmetry, I'll place it in the middle. And let's join 4 with 12. So I'm done with this element. And I'll join 6 with 12. So I'm done with this element. Right? And we get the Hasse diagram like this. Clear? So I hope you have understood it. And there are few more examples that are given in this slide. I'll just go through it so you can see. This is the next exercise that you can try. The answers are already given on the slide itself, so you can try to make it and see that are you getting the Hasse diagram like this. This is the next exercise with divisor relation, and This is the Hasse diagram obtained. Then we have the next exercise. This is the Hasse diagram obtained. And the next exercise is Dm, where m is any integer, positive integers, and it denotes the set of divisors of m. So if D36 is given, that means we have to write all those numbers, positive numbers, integers, which are divisible by 36, right? All the divisors of 36. So 1, 2, 3, 4, 6, 9, 12, 18, 36 are all the possible divisors of 36. And when you check the Hasse diagram, you'll get the structure like this, right? So just try these exercises, and if you have any doubts, you can put it in the comment section and I can give you an explanation for those exercises. So thank you once again for listening to me and watching my video. So subscribe to my channel Maths Hub, and you can always get the next videos, and do like if you find it useful, and believe in yourself and you will always succeed. Thank you.